Okay, so this is just a video going back over multiple regression, in particular focusing on how to get the output to assess assumptions, how to assess the assumptions, and then just a basic recap of how to interpret multiple regression analysis. There'll be another video on how to look at influential scores. For this one, just how to run multiple regression, check the assumptions, and then interpret the output. Okay, so every analysis has to be driven by a research question or by hypotheses. So in this case, we're looking at, do spelling, reading, engagement, and cognitive skills predict literacy skills in primary school children? And of these variables, which are the best predictors of literacy skills? So this is just an analysis we did first in the workshop, then in the tutes. Okay, now it's just a standard multiple regression because there's no priority given to those variables, and we don't know which is the most important. It's one of the things we're going to find out by having a look at the data. Okay, so let's grab SPSS and perform that multiple regression analysis. Here's our old mate SPSS. So we are going to go to regression, linear. Okay, and our DV is literacy skills, IVs are spelling, reading, engagement, and cognitive skills, also known as orthographic and phonological skills. We need our statistics, so we just choose the usual suspects. We grab those and that. We don't need R-squared change because it's not hierarchical. If it was hierarchical, we might use R-squared change. Well, we certainly would if it was hierarchical. This isn't, so we're not. We click continue. Okay, now, crucial thing for testing assumptions are the plots. So we want our Z predict goes on the x-axis. So that's a standardized predicted score for the DV. And it's predicted based on the combination of all the IVs. Okay, and it doesn't include the actual DV because it's just our prediction of what the DV would be based on the IVs. So it's actually the combination of the IVs that's producing. And what we put here on the y-axis is the S-resid. That's studentized residuals. Studentized is standardized with an adjustment for the fact that everything's based on sample statistics. So it's more appropriate if all you've got is a sample, which is what we've got. So we choose that. Now, importantly, we need a histogram and probability plot for the residuals to see if they're normal or not. So click continue to that, and that's all we need for now. So we'll click OK. And we get our multiple regression output. There it is. Now I'm going to start by looking at the assumptions. So we scroll down the screen to the plots. The plots tell me if the assumptions are met or not. Okay, so first thing I see there is a histogram of the residuals. Now I think that histogram it's not perfectly normal, but it's not bad. The only thing that's strange about it is there's a group of people who have residuals of slightly below the mean, who should be just above the mean. So it's just that small group of individuals there. They should be slightly higher in the distribution if they were to be normal. So the tails are okay. You know, it's finished with a little bit of positive skew, but so little you wouldn't worry about it. So I think those residuals are normal enough, and the probability plot confirms that. Okay, you can see mostly along the line at the top and at the bottom, they just wander away a little bit in the middle. That's where those that small group of people in the middle aren't quite where you'd expect them to be there, but they're close. So that's good enough for normality of residuals. The next thing I want to do is have a look at the residual plot. Now, what I expect there is just a box of dots. Okay, I don't want any patterns in that box of dots. And I'm looking at that and I'm saying it's okay. There's no particular pattern. So let me show you what I mean by patterns. Okay, so here are residual plots that you would get if particular assumptions were violated. So top left there, you can see that's assumptions all met. That's what I mean by just a box of dots. On top right, we've got homoscedasticity violated. So at the left-hand side, low values on the predicted score, so low predicted scores, I've made very little error. I've done a really good job of predicting scores there, but as you go across to the right, gradually the residuals increase, both positive and negative. And that means I'm making more and more error as I move across the high scores on the predicted score. Okay, because remember the x-axis is a standardized predicted score. So when I predict scores will be low, I'm very accurate. If I predict scores will be high, I'm very inaccurate. I've got a really inconsistent prediction, and that's bad. That means my regression, who's it good for? It's really good for one set of people, it's really bad for another set of people. I can't generalize it to all people. So that's why that assumption is important. On the bottom left, that's when linearity is violated. So I've probably had a curvilinear association between at least one IV and the DV, and so I get a residual plot with curves in it, and that's bad. And on the bottom right is what I would get if my normality of residuals was violated. I'd have very little spread in the residuals on one side of the zero line and a big spread the other side. Okay, so it could look like that. You could flip that vertically, and that would also be violation of normality of residuals. So when I say you're looking for patterns, those are the kind of patterns to watch out for. You want the one on the top left. Okay, so now we're going to go back to SPSS. Okay, so now we're back in SPSS, and we've decided that our assumptions are met because that residual plot is okay. It's showing a little bit of positive skew, bit of stretch up versus less stretch down, but not much, not enough to worry about. So I'm going to go back to my results and interpret those. And this should be old hat by now. I'm looking at my R squared value there, which is 0.539. So that tells me 53.9% of the variance in the DV is explained by the combination of these four IVs. I know it's significant because I've got the ANOVA box there, and it tells me the F, the p-value, for a test of significance of that overall R squared. From there I go to the coefficients to look, so that first part, the R squared, tells me, answers the first part of my research question. Do these IVs predict literacy skills? Yes, they do. And what's their relative importance? There I look at the beta weights. So you can see there that the beta for spelling is the highest, 0.385, it's significant. And so is the beta weight for reading, that's also significant. Then engagement is not significant. And then cognitive skills, the orthographic and phonological, is significant. So I've got three significant predictors. Strongest unique association belongs to spelling. The next one is reading, followed by cognitive skills. Engagement is not significant. And because my assumptions are met, I'm reasonably confident of these results, but I still want to check for individuals that might be influential. And we're going to do that in the next video. So I've got here a bit of a summary. Assumptions are met. I still need to check for influential scores. Combination of spelling, reading, engagement, cognitive skills explains 53.9% of the variance in literacy skills. There's where I know it's significant. The F and the P, and then in order of importance, if I could spell, spelling, reading, and cognitive skills all made unique contributions to the model, while engagement did not. And next job is influential scores, and that's in the video Multiple Regression Part 2.